There we go.
GitHub branching best practices. Okay.
Uh,
That looks a little hairy. Let's see if we can
looks,
find something simpler.
it's kind of scary. Where's my glasses?
That's pretty traditional, but it doesn't, it sort of assumes you know a bunch. Comparing workflows. This goes nice and slow. Okay. This is pretty much it.
Okay.
So just as an example, so here's this RChain API thing, and the presumption is that, you know, not everybody in the world, but some significant number of people are grabbing the, you know, they're cloning this thing and expecting it to work, right?
Okay.
So if I have a wild hair idea and I commit it to the master branch, then the next guy who comes along and grabs this thing expecting it to work is going to get my wild hair idea, and it's going to crash and he's not going to be happy, right?
Okay.
So if I make a new branch for my wild hair idea and I stick it on a branch and I can commit all over here, and then people who are grabbing the master branch are not affected by my work.
Okay.
And then once my wild hair idea is kind of mature, then I can make a pull request out of it and I could say, hey, everybody, what do you think of my idea? I think it works.
Okay.
And then if they like it, they can merge it and then it becomes part of the master branch.
Okay. So have the master branch, but when you're working on different ideas or features, create a branch to that, work through the idea until it's solid, and then merge it with the master branch at some point in time.
Yep, and you'll see this. So this is how the core team works. So these are, you know, there's 20 feature branches going on because each developer can't wait till the next guy's done. They're all working in parallel, right?
Right.
So one guy has, and these work in progress things say, well, you know, I made a pull request, but it's probably not done. It's, you know, you might want to take a peek at it, but it's still work in progress. Whereas this one says, you know, we're going to get rid of this thing altogether. Why was it there in the first place? Frowny face. And Kent approved. I think he might have been the one who put it there in the first place. So I'm not sure why this hasn't. And then they have a robot. They have a little bit of process to their thing. It's not just that some people like the idea. The robot has to go and run all the tests.
Okay.
And then the robot actually does the merge.
Okay. And that's that automation aspect to GitHub that I heard somewhere, or I think maybe Mike Loomis was mentioning that you can automate the merging of pull requests.
Yeah, they've got all kinds of stuff you can. You know, the GitHub API has got all kinds of stuff.
Okay, sweet. Well, yeah, it's in. I plan on kind of digging, now that I'm getting oriented on GitHub, I plan on digging deeper into it to get a better understanding. But at least I've got something to kind of go on.
Okay, so here's one, get rid of SIG algorithm. It's kind of, I would highly recommend that people just browse these recently closed pull requests, and
Okay.
anything that seems wildly interesting at all, like Peak, right?
Right.
Rolling Peak follow-up. I don't know why it's a follow-up, but we might be able to find the original Peak thing. And so
Okay.
what did it take them to do Peak? Well, okay, so here we can look over here. Here's all the changes. What's the first one do? Gosh, I don't know. I don't completely understand this. So we went from yielding res to yielding the result of executing to just returning executing. I'm not really sure I understand that. That's kind of weird. Oh, maybe they changed the way execute works. Anyway, so you start by going, I don't know what the heck Scala is. I don't know what's red and green, and what's anything, right?
Sure.
But if you start with something you're interested in, you're much more likely to learn stuff and it'll stick than if you go, okay, let's open page 1 of the Scala book.
Right. Exactly. Yeah, I agree. So, and Peak has been a talked about feature for quite some time, and it's a key aspect of cost accounting, so in making things happen. So that'd be a good one to kind of take a look at.
Now, I wonder if we could get to the point where that actually makes intuitive sense to you. So where's Peak here? Hold on. Rolling Peak. There it is. That's the main one.
Okay.
Okay. So if I just did I'm going to get Scala. I haven't done this in a long time. That's Hello World in Roland, right?
Okay.
Jim, you're following along with me?
Yeah.
Okay. And now let's make a little library. And Bob and Sue go to the library.
So what are we going to do a peek here, or what are we doing?
Yes, I'm going to sort of. We're going to do an example that maybe motivates Peak.
Mm-hmm.
Okay, so we got a library thingamabob, whatever that is, book status channel, whatever that is, Bob, whatever that is, and Sue, whatever that is.
Mm-hmm.
Okay, and we're going to take the empty map and we're going to stick that at the book status channel.
Okay.
All right, and then we're going to make a library sort of borrow method, and you borrow a title, and then you return channel equals. So this, we have to find out if the book is available, right?
Okay.
So we go to that channel and we find out what's there. And then boringly, we have to remember to put it back. Otherwise, the next guy who, so this is a, okay, let's add a little comment here. How do you do comments? Okay, so this is a dictionary that's going to tell us for each book title whether it's checked out or not, right?
Okay.
So we're going to get that dictionary, you know, that map into this book status local variable here, and that's going to take it out of the channel. But then if somebody else went to borrow a book, they would just sit there waiting on this channel because there's nothing there now, right?
Oh, gotcha.
Okay, so we better put it back.
Okay.
This isn't a good example. Okay, so now we can say if book status get title, if that's true, in other words, return channel, book already checked out. Else, so now I kind of goofed it up here. Because if the book was already checked out, you want to put the same book status back, and otherwise, you want to take the book status dictionary, and then at that title you want to say it's checked out and put that back in the channel. So this turns out to be not a very good example for Peak because we actually do want to lock that channel, and we want to do a transaction in this case. When we're checking out a book, we actually want to change what's at that channel.
Mm.
But if we had another method down here, so here's something you might do. So you ask the library, is Alice in Wonderland available? And it'll go get its map of titles to status, look up your title, and give you back on the return channel. It'll tell you whether that book's available.
Right.
But then again, if I asked for book 1 available, so now it takes it out of that channel. Now there's nothing at that channel.
Okay.
If book 2 is available, and I'll just get waiting to see if that book's, so I got to put it back, right?
Right.
Okay, now this was kind of boring. We took this dictionary out only to put it back, and we never changed it in this method, right?
Mm-hmm.
So I don't know how it's spelled these days, but this would let us get the value out of this channel without taking it out of the channel. And that's called Peak.
Okay.
Now, and the main thing is, if you have 2 different blocks running this is available method, they don't step on each other's toes. It doesn't matter which one you run first. Does that make sense?
Yeah. Well, I was just reflecting on the notation for peak. What is it? So it's that for at book status, and then.
Okay, I was hoping that didn't matter because I didn't look it up.
Oh.
Why? Does
Well,
it matter
okay.
to you?
Well, then okay, that's fine. So it's just more the concepts that you're, and that's something that I'm more familiar with is what the concept of peak is. So I'm following along the lines there. So I thought that you knew what the I thought you were getting to how to the actual code for peak, but if you don't, if that's not part of your explanation, that's fine. I would just want to be clear on what the goal of your explanation was, which is
We might as well look it up while we're in the neighborhood. Where is the? They promise to put examples in the example directory whenever they do peak. So whenever they do new features. So let's just do Rolang examples 6 days ago. That's a good sign. Frowny face.
okay. So they don't list any code examples of how someone would use peak in a Rolang smart contract.
I don't see one.
Okay, and that's important.
Okay, well, they use exclamation point in
Where do you see that?
the Learn Rolang by example, Joshi's.
Have you tried it? Does it run?
No, I haven't tried it.
Yeah, I'm trying to look at the actual source code to the. Let's see. The other place that's useful to look.
And Jim, if it's in Josh's repository, it may not be current because the peak feature is something that they've only just completed the code complete on.
But I think we had the specification beforehand.
Oh, okay. I didn't realize that.
Well, yeah, and then they sort of arbitrarily changed the syntax lately, as far as I could tell, which is kind of weird.
That's not good.
Yeah, it was like really weird.
That's those types of things create confusion when it's not disseminated to everyone.
Yeah, see, they use this double rocket thingy for no reason that I'm aware of.
Okay.
What is it? What?
This is the syntax they actually implemented.
Ah.
So we're thinking that is peak or somehow related to the use of code for peak.
Well, we can try it. I mean, I have the latest R node running on our node Bob. Right?
Yeah, I mean, it's pretty clear this is what the syntax they use, but yeah, you should definitely try it.
Okay.
And I guess the other thing about peak is peak never blocks. I mean, peak always returns, right? If there's nothing there, you get nothing back. Or is that,
I don't know if that's the case.
I guess we can test that too. So that's our node Bob. So I'm trying to think what I could. Uh, that's interesting.
Are you winning, Jim?
Am I waiting? I'm trying to run an example here.
Winning. Are you making forward progress?
Oh, I think so. Let me see. Try to run this again. Okay, so this this ran. So the syntax was taken. And what I do is I write hello out to this once, and then I 1, 2, 3, 4, 1, 2, 3, 4. I read it 5 times. And I'm not sure what this, oh, this is just other stuff in the tuple space here. So if I look at the, I have to look at the log, right? What? There's nothing in the log? Okay, where is the log? Oh, the log comes right out to the screen. Okay, so it makes it a little bit hard for me to see here. I better start another terminal. Okay, rnode eval xx.row. And we didn't get any output. To the log. Yeah.
Well, it goes to stood out. I mean, it goes to the nodes logs.
Well, it just shows evaluating, right? There's no output.
Yeah, but stood out doesn't go to the screen from where you invoke eval. It goes to the node's logs. This is the wonderfulness of our node, remember?
Right. But this is the log on this window.
I don't believe so.
Where this is where I ran the R node.
Yes.
This
There's another R node that's actually doing the evaluation, right?
Right. And the standard output from that is here. You're saying that this is not.
I don't believe so. Where's the one that actually says, here's all my blocks and I'm doing this and that and the other thing?
That's this guy.
Because that's where stood out goes in his log.
Right. Well, let's look at hello.row.
Somehow we don't have two things connected.
Okay, hello did not do anything. It did not write anything. Hello. I don't know where that came from. What else we got there? Asterisk.row. This is I don't know why that doesn't do any output. Let me just change it. New hello world. Insert comma. Standard out. As row IO standard out. In contract hello return. And my channel. No. Undo. Okay, so this should do some output, right?
It should.
Um, okay, so here's the hello world down here.
Okay.
Yeah.
Now try peeking the. Let's see. Change
Okay.
one of those things to a peak. I think you just have 1-4 expression. Oh, you don't have any.
Yeah. But if we look at the, if we look at this one, no, this is pretty straightforward. We write hello to X. And we read it back and we peek in parallel and we get nothing.
Well, okay, so put stood out hello world just inside the curly braces. And then anything in the string doesn't matter. Yeah. Well, probably did. Yeah.
Okay, and what happened to our
Pretty weird.
We didn't get it, hello world. That's very weird because
Oh, your stood out isn't bound to anything. First line. You don't have row IO stood out.
I see. Yeah. Thank you. So, that should work better. Okay, well, we got the hello world this time. What?
Which one did we evaluate there?
Did I do the wrong thing? I did. We're in the wrong program. Okay, now we got all the hellos.
Oh,
1,
okay.
2, 3, 4 hellos. That's interesting.
Stupid computers do exactly what you tell them to.
Okay, and then if we so we write hello, we get a hello world 1, 2, 3, 4. Now what happens? What happens if we don't do this?
Oh, right. I'm pretty sure Z won't get bound. I'm pretty sure that 4 won't make progress. But
Okay, so it does require. It would have sort of been useful to see if you could check to see if there was anything waiting or not, which you can't do with this.
no, I don't think there's anything in the architecture for that.
So you're going to. That's interesting. I mean, there's all kind of race conditions you can think of if you have reeds and peaks. Who gets done first?
Yeah. So then what's going on in cost accounting is I guess they want to be able to look at channels without creating a transaction that, a write transaction. Because as long as as long as everything that's going on is a read, then it doesn't matter what order things go on.
Right.
And therefore you can, like if you got two blocks that both read from X, then you can merge those 2 blocks because it doesn't matter what order they go in.
Right.
And that's, I guess, the cost accounting has a lot of places where it only needs to read. And if in previous to peak, every read also needed a write unless you wanted to change what was there. Well, it needed a write in any case, even if you didn't want to change what was there.
Okay, so now if on another topic here, if I okay, so I have this node running, right? And there's five keys that are bonded to this node that I have running here.
Okay.
So if I want to connect to this, okay, how do I know what the XXX here is in the Bootstrap address that I have to give to connect if I want to connect another bonded node to this? Do you remember offhand?
Well, I believe it gets spit out during, in the first parts of the log. Maybe they've made the logs a little bit more quiet lately. I don't know if it's still there.
Yeah, that could be a problem because
well, the other thing is that the logs all go to a file, I think now, as well as like the console or whatever. So if you look in is there a directory, like your RSpace directory and stuff, and the Genesis and stuff like that?
My R node is is empty here, but this is where I'm starting it.
What's the internet name of this Arnaud Bob machine?
It's arnaud-test.robot.net. It has a couple other names too, but That's the one we put on it initially. So it should be right in here in this configuration. It should tell us this is it. No, this is a bootstrap we tried to do. That's no good. This is it here.
That looks.
Listening for traffic on here.
Yeah, that looks.
That's it.
It certainly got the right form. Is 206.189.213.135 one of the external IP addresses for this machine?
I believe so, yeah.
Okay, then that's looking more and more likely. The first part is probably a public key or a public key hash or something. 206.189.213.135. That's it. Excellent. Okay. Sorry, that was just an aside. Oh, I thought maybe you were going to test it.
Well, I did want to test it, but what in the world is this?
Maybe a new line and some spaces or something?
Whatever. Okay, found it. Okay, so yeah. Well, I don't have. I have to spin up another node to test it right now.
Right.
But I did want to do that because I want to run the .11. I think testnet's back at the .9 or something.
Oh, really?
Doesn't have the. I don't think it has the peak and stuff. And I wanted to just make sure that I can, I can propose from a node in the network, which you can't do on testnet. I mean, you're not when you're running on testnet, you're not bonded. It's not clear we're really exercising fully the well, I guess we are. Really, to some extent, I mean, why bother to run a node if you're not validating? I'm not sure I understand.
Well, there's not any mature features yet, but if you just want to do listen for data at name, for example, if you want to run the equivalent of a block explorer,
yeah,
an indexing service or something like that. I mean, there's plenty of Ethereum nodes that don't do mining, right?
Right. Yeah. And I guess, you could, and I'm figuring this out exactly, but I suppose you can do local, rolling. It's not persistent, whatever.
Right.
Although I'm not sure how that would, how that would, I mean, you would end up building a big tuple space that would never get used. I'm wondering, if that would be a healthy thing. Uh, So what did you want to do this morning, Dan?
Let's see. Started writing down some what I've been up to. Okay, so I wrote a little article on Python programs, which happens to have object capabilities in it a little bit. That would be a quick one. I got a $25 Internet of Things board that does secure JavaScript.
Cool. Sweet.
Yeah, the thing said like allow 4 to 6 weeks for shipping or something, and then it came the next day.
That was a nice surprise.
Or I thought it did. Okay, so home.
Yeah, a lot of those things, they try to get you to pay like $20 for 2-day shipping, and if you don't pay it, if you take the free shipping option, it comes just as fast.
So this is the thing I bought. I bought the $25 version. I don't know where the shipping comes in. Anyway, and then the way I discovered it,
And so how does that hook up to the internet? As
it's got Wi-Fi and I think Bluetooth or whatever.
Yeah.
So these Moddable guys have been following the secure JavaScript stuff for a while, and I've tinkered with their stuff a little bit, but not very much. And then they did this release where they actually, and Mark Miller was very happy about the way they explained secure JavaScript. Secure ECMAScript, this bit here. Freezing built-ins. Anyway, I don't see anything about object capabilities per se. Anyway, so I can run secure JavaScript on this little $25 board. So I don't know what the activation energy is. I don't know what it actually takes to actually do it. But if you guys wanted to watch, that's a possibility. What's the other thing? GraphQL, where'd that go? I watched a really cool talk on type-safe GraphQL servers with GADTs. And GADTs are basically Idris data types.
Okay.
The stuff we learned about ordering ice cream.
Mm-hmm.
If you wanted to spin your propeller a little faster, you could watch him build type-safe GraphQL servers using those.
Okay.
I guess that's what I put there too. This is where I put the Moddable thingy. Should I fly through this one real quick?
Yes.
Okay. So we begin our story. There's a thing called Lobsters, which is a little bit like Hacker News, except more civilized or something. And I ran across it from Dave Beckett. Anyway, so somebody wrote writing sustainable Python scripts, where he starts with this 10-line FizzBuzz thing and then adds documentation and testing and this and that and the other thing. And I'm like, oh my Lord, this is a little overboard. You're making Python look bad. On the other hand, I do have a similar process. You know, when somebody hacks up some little piece of Python code and wants to put it into production, I go, oh, hang on. So let's look at what I go through to do this. All right, so here's a little FizzBuzz thing. Is anybody not familiar with FizzBuzz?
I'm not, no.
Okay, so it goes 1, 2, fizz, 4, buzz, 6, 7, 8, 9, buzz. So if it's a multiple of 3, you have to call out fizz, and if it's a multiple of 5, you have to call out buzz, and if it's a multiple of both, you say FizzBuzz.
Okay.
And that's what this Python code does. You run it and you say, you know, FizzBuzz 10 through 20, and it goes, okay, for n in 10 through 20, the first time it's going to go n mod 3, and that's not going to be 0, but n mod 5, so it's going to skip that one and skip that one. But n mod 5 is going to be 0, so it's going to print out buzz for 10, and then it's going to go to the, and so forth. Does this much code make sense?
Mm-hmm. Yeah.
All right. So I have a process for turning this into production that I quite enjoy. I just did it in a gist. Do you guys either know what gists are or want me to skip what a gist is?
Just a file on GitHub, right?
It's kind of cool. You just have something you want to go, but it's like it's some error message or 20 lines of code that you don't want to make a whole repository for, but you want to share it with the other two guys that you're talking to just now.
Oh, okay, this is helpful because I see gist all the time, and I have no clue what it is.
And it's that quick to make a gist. Okay?
Okay.
And you can have multiple files in your gist, and then it turns out that this is actually a Git repository, and you can make revisions and check them out, and then you can sort of graduate it to a real repository and stuff like that.
Okay, so that's a gist.
Right. So you just go gist.github.com and type in whatever you want. So, like, this is me trying to figure something out, right?
Mm-hmm.
Okay. So I did I took the 10 lines of code and I pasted it into a gist, and then I did these steps. Okay. So if we have some code and we're going to put it into production in my shop, we have a code review process, and the idea is that if you write some code and then tomorrow you break your arm and you can't come into the shop, somebody else in the shop knows how the code works, right?
Mm-hmm.
And they're willing to maintain it. They don't go, ooh, that's Fred's code. It's stinky. I hate it. I'm not going to touch that. Right?
Mm-hmm.
So the bottom line here is this code I would be happy to maintain?
Right.
All right. So I'm not going to go over the whole thing, but you're welcome to at your leisure. And then this guy, why don't we do this? See, can I do this? Right. Then we'll put this. Oops. Ooh, that's not what I wanted to do. There. Okay. So this guy, the first thing he does is write documentation. Okay. So I said, well, I appreciate writing documentation first. It usually takes me a few iterations of prototyping before I know what it is I want to document. And then he does all this stuff with command line arguments and testing and stuff. Well, at some point he gets to testing. Tests. There we go. I said, I haven't made a strict habit of test-driven development, but I do find factoring out tricky bits of logic and adding tests for them frees my mind up during development, and I do make it a rule to write tests before fixing any bugs. Anyway, okay. So you've got this code here, and if in Python, if you imported this code from another module, it would go and start printing things out. Okay. And you're like, wait a minute, whoa, I don't want it to print things out. I just want to use the FizzBuzz code, right, in my code. Okay, so what you do is you say, you put it in a function, def main, and then you say if name equals main, which means if this thing was invoked as a script, then run the thing and print everything out. But this, if it was just invoked from another module, then the only thing that happens is the main function gets defined. So as a rule, module level code shouldn't do anything but define things. Okay, so then this is a little bit about OCAP discipline. Okay, to facilitate patterns of cooperation without vulnerability, object capability, OCAP discipline says that the only thing globally accessible should be immutable data. This also supports testability. That's a great article by Nico Havery about, this is the guy who teaches everybody at Google how to do testable code. They actually have little things in the urinal at eye level about making your code testable. Okay, so argv and stdout are IO, or at least they're sources of non-determinism. That is, you could run this code twice, and depending on what command line arguments were given, the function would behave differently, right? So object capability discipline calls for passing these around explicitly. In other words, they should be passed in here like they are down here. Of course, we have to get them from somewhere. In an object capability language, they would be passed directly to main. We simulate this down here. So if name equals main, then we get the cheat a little bit, and we basically sort of grab what they call ambient authority, and then we pass it along to main. So now main uses whatever argv and stdout you pass it, and so you could test this function by making up 100 different argvs and 100 different stdouts and passing it and seeing what this function does. You don't have to connect it to the real argv and the real stdout. You can use it, you know. Does that make any sense?
Yeah.
Right. And now notice that if you give this thing the same inputs, it's always going to produce the same outputs. Now it's a real mathematical function in that sense. All right. Quick and dirty arg parsing. The code's now testable, so we start looking inside. Mixing arg parsing with other logics doesn't smell right. This little bit here, we're grabbing argv1 and stuff while we're at it. Now he adds, he or she, I'm not sure, adds this much code for parsing arguments. I'm added 2. So I just assign, I take argv1 to 3. Argv0 is the program name. And so I slice 2 items out of argv and assign them to low and high. Now, could be that there aren't any argv, right? You just typed fizzbuzz, go, and you didn't provide any. So this would be an empty thing, and it wouldn't be enough things to bind over here. So it says if we just invoke this script with no args, the resulting traceback is often enough of a usage clue given the user base is a handful of devs in the shop plus Jenkins. So there's going to be a little traceback, and it's going to say, you know, low, high equals argv1 to 3. Oh, the arguments are low and high. Now I remember. So it's not real pretty. It's a traceback and stuff like that, but it's sort of close enough for rock and roll. Otherwise, this thing here is bigger than the 10 lines we started with, right?
Mm-hmm.
Okay, and he also changes the 3 and the 5 into parameters. And everybody knows that fizz is 3 and buzz is 5. Nobody has ever changed that in the history of computing. So that's totally over-engineered. Parameterizing fizz and buzz adds testing and maintenance burdens. Unless we've got a customer requirement, let's skip all that. Okay, I like to keep main functions small and separate logic from I/O. Using yield in place of print is particularly convenient. Let's add one quick doc test while we're at it. So now we've got a nice fizzbuzz thing that doesn't do any I/O. You just give it low and high, and it gives you a sequence, and then this test function turned the sequence into a list. Using yield makes it lazy. That's kind of a long story that I'm not going to go into. Now, if you want to use this fizzbuzz thing from another module, it's kind of clear how you do it. This thing tells you, you pass it into integers, and you get back something that you can turn into a list. And then our main function is nice and small. Now we can document test and usage with the module docstring. I actually started the module docstring early in the process. but I didn't commit it till the end in order to make each commit demonstrate one part of the process. So simple FizzBuzz generator, the game proceeds with players announcing the numbers increasing sequentially except for multiples of 3 and 5. I don't really like Python because you can make your documentation testable. So I just say usage is the string FizzBuzz120. And then I'm going to make stood out a little string IO. In other words, it's going to print into memory. And then I'm going to call main on usage.split. So I'm going to take this string and split it into the kinds of things you get from the Unix command line. Like I said, argv0 is the name of the program, and then this will be 1 and that'll be 2. And then stood out. And then after the program is done, it printed into memory. So now I'm going to actually sort of print it into this test harness world, and it's going to print stuff out. And then in this test harness world, I get to use ellipsis. So it's going to do 1, 2, fizz, 4, buzz. And then I get to use ... because it's boring from 7 till 14, and then fizz, buzz, 16. So if I what in the world? Oh. Oh. It's kind of interesting. Hold on. Using Python 3 here. Okay. So if I actually screw this up and write that, then it'll tell me that I got my documentation wrong, which I think is kind of cool. Likewise, if I get my implementation wrong, it'll tell me that too. And it's quiet normally if it succeeds, but you can also do, you can put a -v on the end, and then it'll be a little bit noisy. So I really like the Python doc test stuff that way. So the module starts with this thing that tells you a little story and actually demonstrates the usage of it, and then it actually tests all the code. So in this example, our 10-line working prototype is turned into 60 lines of code. If a developer asked me to review the original 10 lines after using it successfully for a few days, and if the cost of a failure was just a few minutes, I might not bother to touch it. Because maintaining less code is almost always better. There's exceptions to that, but we're now maintaining 60 lines of code instead of 10 lines of code. But the code did mix I/O with logic in a way that makes me uneasy. More often, the cost of a failure is rerunning a Jenkins job that takes hours, and even in early prototype form, scripts are usually longer than 10 lines. Applying these techniques turns up a bug or two, or at least clarifies the security properties of the code. In this case, of the 60 lines, 25 are documentation, 10 are just real simple script output. The main function is 6 lines that clearly do nothing but parse args, call a function, and output the results. And the script IO thing is this bit down here is formulaic. The FizzBuzz function retains the structure of the original 10-line prototype, which is 4 lines added for documentation testing. So that's what I do with Python stuff to change it from prototype to production.
Okay.
Nice.
And I kind of do that with all the programming languages I work with. Like, you can do the same thing with JavaScript and Rolang. In some ways, you have to do this. You can't do anything else. In some ways it's not. The stood out in the clock thing are a little bit like argv and this. They make me a little uncomfortable about the way we did that. The supposed power box, which is actually not a power box.
The clock thing? I'm not sure what you're referring to.
Clock in Rolang, there's a clock.
Oh, okay.
Right. So that's a source of non-determinism, right? You know, depending on what time it is, your code might produce different output.
I didn't realize there was a clock in Rolang.
There is.
There is.
Where did they put it? Block time or something.
Oh, for the timestamps, for the
Not
block timestamps.
something like that.
Oh, okay, that makes sense. Yeah.
Yeah, you can get at the block time stamps from Rolang.
Okay. Well, yeah. Now that makes sense.
So,
Cool.
all right. So now let's measure the hack. Ooh, that was interesting. Measure the activation energy of this modelable stuff. All right. I'm going to put that away. So we got this. All right. I guess we're done with this. Okay. Time check. 10:20. Let's see how long this takes. We're going to try to get something to happen on the gizmo.
No. Okay.
Getting started. I want the word getting started and a big button.
Yeah.
So that's
Click here to get started.
failure number one. Moddable and GitHub license about team FAQ blog. Products. Getting started. There we go. Okay, model 2, getting started. Blah, blah, blah. Components, pit out. Yeah, I believe it. Okay, looks like I have to do this. What is this? You're making me do a lot of blah, blah, blah. Is that the first thing I type? I doubt it. I've never heard of that command. I doubt that's going to work. Yeah. Now they're making me think.
Mm-hmm.
Mac OS. Skip, skip, skip. Oh, this is still under Mac OS. Windows. I'm a lowly Linux loser. Okay. Now we're into stuff that I sudo apt-get install. That should work. So GTK is a windowing toolkit. I'm familiar with that. I don't mind installing that. Create a projects directory. Mine is lowercase p, but whatever. I'll give it another name. Whoa. Yeah, okay. Can download to any directory. They just put it, okay. Right. This is more normal stuff. So, if you're, hello. Oh, I've already got a model thing. Let's pretend I didn't. So if we're new to GitHub at all, this is very much the first thing you do when you're using somebody else's GitHub code.
Okay.
It'll say https github.com and then whoever they are, and then the name of their repository. And you git clone that, and now I have the whole Git history of I have a whole clone of the project, and the clone is the whole history.
Okay.
I have every version that they've ever checked in.
Mm. And that's creating a separate repository on your GitHub account?
No, this.
Oh no, I'm sorry.
Right.
It's downloading it to your local machine. Gotcha.
Right. So I use this weird Emacs thing, but one of the things that it can do, this is a normal Git, this is sort of comes with Git, is a tool, and looks like, so this is all the history of their project. Woo, they've been at it for a while, and they keep their history in a straight line, except for a very few exceptions. And we can see the changes they made and blah, blah, blah.
And you say this tool you got with Git?
Yeah, it's called, I think it's GITK. Yeah.
The Git kit.
Well, there's a GUI toolkit called TK by John Osterhout and company way back when.
Right, but I didn't think that worked on Windows.
Yeah, TK works everywhere, sort of. When you install Git, you also get visual tools like GITK and Git GUI, it looks like. What is this RIP tutorial? I don't know, but it was the first thing that came up in the, oh, this is more like it. This is the standard Git documentation. All right. All right, so we cloned our stuff, set up the moddable environment in your bash RC or whatever. Okay. Two Ds. All right. Go into the command line tools. Make is a very familiar tool. Oh, while it's doing that, short walk down history lane. My first job out of college was at Convex, a company that made supercomputers, and I was in the development tools part of the company. Convex OS tutorial papers. So this is like all the Linux tools from the 70s and stuff. Writing papers with nroff. Somewhere in here is Make, I'm sure. I think I actually learned Make on OS 9 before that, but Make, there it is. Oh, part 4.
So some of the stuff that we're seeing on the screen is what you were involved in many years ago?
Well, no, I mean, no, so the C programming language, was done in the, I don't know, the 70s. So if we go Wikipedia.
I think it was 68, 69.
Okay, so Make is a tool that goes back to 1976 is the point here.
Oh, okay.
And so my first job out of college, they handed me this book and said, here's what we do around here.
Mm-hmm.
Oh,
Gotcha.
Is it signed by the people I work with? This one's not. Martin Stryker was my boss at the time. And I didn't realize how lucky I was to have him. That's the guy.
Oh, okay.
I guess I didn't really use Make until 79, and I thought it had been around forever.
Yeah, so he calls himself a Ruby and open source nerd, and so he was my first manager. Okay.
Cool.
So that walk down history lane, it's done. Where were we? Here we are. Okay, we're gonna put those tools in our path so that when we invoke commands, it will find them. Install the screen test desktop simulator and XS bug debugger applications. Cool. The XS bug thing looks kind of cool. I hope we end up using that. That looks happy. All right. I mean, the JavaScript interpreter and stuff in your web browser is a ginormous piece of software. And then this thing is a JavaScript interpreter that goes on a little teeny board like this. So it's much, much smaller. So if you wanted to like know how one builds a JavaScript interpreter, you could just read all of their source code in an afternoon, which is kind of cool. Oh, good. I was hoping we got to do this. All right. So remember, they wanted us to install GTK, which is a graphical toolkit or something. So so these Moddable guys didn't write the code that does these menus and stuff. That was the GTK folks, but the Moddable folks wrote a debugger, I guess.
Okay.
Here's a little bit of JavaScript. Okay. Verify the host environment. Okay, I guess they want us to leave that running. I don't know. Okay, so they've got a hello world example here. Oh, that's also here. Right. Trace message, blah, blah, blah. There's a debugger statement. All right, what does this do? What did that do? Oh, wow. So my impression of their stuff is you write a little bit of JavaScript and then you sort of write a little thing that says, I'm using these 5 JavaScript functions. So when you build me a custom JavaScript engine, please include these 5 functions because those are the ones I need on the board at runtime.
Okay.
Complete host environment setup for Linux. Did we already do that? Yes, we did. ESP8266. Is that what we have? I guess. I don't know. Uh-oh. ESP32. Ah, okay. Create an ESP32 directory. All right, download and untar the 64 or 32-bit toolchain. Okay, downloading 42 megabytes of GCC stuff. Copy the extracted blah, 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 ESP32. Hi, Eric. We are in a strange part of the world right now. I'm not sure what brings you here.
Hey, Eric.
Hey, how's it going?
Doing all right.
Is Eric the one who did the intro to GitHub, or?
No, he's Eric's the blockchain artist.
Ah, okay. So the part of the world we're in is this is a little board that does secure computing in a way. So we're testing what it takes to make it blink or whatever.
What's it called?
Moddable 2. Moddable with 2 Ds.
Oh, and it's got a screen interface?
It does.
$25?
$25.
Jesus.
Yeah. My comment was sold. Where was it? Where was it? There you go. Okay. All right. We're so that's some compiler gook. Clone to this thingy. What is that? Whatever it is, it's substantial. Use the 3.1 version. Oh, there's these things called Git submodules that I barely understand, but it's cloning several things. Mm-hmm. Open source software development is such a blast. You're using millions of lines of source code written by thousands of people all over the planet all the time. And it more or less works. Okay. And this particular arrangement is going to end up with a pretty small trusted computing base on the device, I think. All right, so okay. Install the packages necessary. Okay, compiler, Git, we already have. This is a thing that grabs things off the web. Make, we talked about. Ncurses. These are all pretty familiar doodads. Python serial, I don't know if I've used that one before, but it's kind of obvious what it does. Serial port connections. gperf is that's all done. Set. Okay. IDF path. Install. Oh. It wants to install some packages system-wide. That's mildly uncomfortable, but I'm going to let it do that. Oh, wild. I don't have easy install. Okay, I'm going to make a virtual environment. Now I will. More toolchain stuff. Wow. Embedded development. Connect the ESP32 device to your Linux host with a USB cable. All right. Stand back. We're doing hardware. Now, so there's the board itself has got a USB connector, and then there's this little programmer dealie. Connect the ESP32 device to your Unix host cable. Well, what? Wait. Plugged in the wrong end. Okay. Micro USB. Ooh, blinky light. Look at that. Drag 2, drag 4. Oh, look at that. It's got something already on it. That's kind of cool. I don't know if you guys can see that. But there's a little thing that says drag 1. You can drag it around with your finger. Okay, is that what it was? All right. Determine which of these. I'm going to do this. What's Darfon Electronics Corporation? Okay, I think that didn't quite work. I think I'm going to try plugging in the other way. Good night. Still get drag 1 through drag 4. Ah, TTY USB 0. Okay. All right. Verify the setup by building hello world for the blah, blah. Okay. Doing a bunch of C compiling stuff or something. Oh, permission denied. They told me it might happen. So it's in the dial out group. And I'm not. I'm decalling at work. Okay, I'm in that group there now, except sometimes you have to log out and log in. If I just start a new, boring, I really don't want to log out and log in. I'll lose all these windows and stuff. But I don't see an alternative.
You can just log in. You don't have to log out.
Oh, right. Oops.
You know, if you do an SU to yourself, it should be fun. It should be fine. But
Like that?
yeah, that'll do it.
Is it, or is it like that?
Like that, right?
Yeah. Now I got to remember all these environment variables that I set. They told me to put it in my bash RC, but I didn't do it. Is this the step I was on? Oh.
Hmm.
So I don't see anything on the screen here. Verify the setup. Because it looked like this is going to the device. Chip is blah, 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 blah. This is kind of cool. Features Wi-Fi, Bluetooth, dual core, blah, 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 blah. Wrote a bunch of bytes. Leaving, hard resetting via RTS pin. Suppose I just plug in what I think might be just the power port. Nothing. Okay. Oh, maybe it was doing the breakpoint thing in the debugger. Ah. Well, it printed it there. Oh, maybe it came back out the serial port and went here. Okay. So this one might do something on the screen. PIU. So these are all the JavaScript things here. It's building us a JavaScript interpreter. And what it's doing now. Okay, now it's connected to the device. It's writing 400K of stuff, whatever. Resetting. Oh! Look, there's little balls bouncing around. I don't know if you can really see that.
You want to stop share? Stop sharing your screen. We'll be able to see it a little better.
Oh, there you
okay, there we go. Yeah. Yeah. Sweet.
Well, we started at 20 after, so it was half an hour. It was an
Okay.
activation energy. So what are we doing here? That's not the program it's running. Where did we do the excess bug thing?
What does the debugger show now? Anything?
Well, it's still looking at the hello world thing. How do you start the thing? Let's see. Well, that thing's still running there in Hello World. We're in this one. The balls are still bouncing around. Well, hard resetting. The balls are still bouncing around right now. Automatically launched when deploying debug builds and connects to the devices via USB or over Wi-Fi. That looks like debug. Automatically launched when deploying debug builds and connects to. Where are we here? Samples PIU. Who knows what that is? PIUMC. I know what that is. Yeah, because I don't know what skin and texture and behavior are. Well, it's working as advertised. I don't quite understand all the parts yet.
Well, maybe next week you can show us it actually doing something.
Something of my design, yeah.
Before we finish today, I did want to ask you about the ambient calculus. I don't know if you read the ambient white paper that came out this week.
No.
Are you familiar with the ambient calculus?
I've heard of it. I have a vague notion of what it is.
Okay, well, I feel like we've talked. There was talk about it at one point. I guess it's another process calculus.
Right.
And this ambient protocol white paper is a peer-to-peer machine. What is it exactly? Decentralized web. The Ambience protocol to create and verifiably execute distributed programs in the decentralized peer-to-peer networks. The main contribution of the Ambience protocol is a process algebraic specification of its purely functional, safe, and composable programming model.
Hurl me an Earl, dude.
I'm in the GitHub. I mean, it seems a lot easier to read than the PDF.
Yeah, can you stick a URL in one of the channels around here?
Yeah, I put it in the chat. I'll also stick it in the computational calculus, I guess is the place to put it.
Okay.
Let me give the main page at least.
Oh, I always forget there's also a chat for this thing because it goes away at the end, which is I really don't like it.
Mm-hmm.
Right. Well, yeah. It gets saved for me, but
Hello? Oh, that's the abstract.
yeah. So you can look at the PDF if you want. I find the GitHub easier to read.
Origins of the web, according to. All right, fine. Blah, blah, blah. Hope, okay. Motivation, blah, blah, blah. Nothing technical so far. Okay. Okay, still nothing technical.
So it's apparently deterministic.
Okay, now we're getting to it. Ambient N with nested process P. Okay, M dot P is like our 4, I think.
An ambient is almost like an environment. I mean,
All I know is that it's denoted by N so far. But M dot P is familiar from other pi calculus stuff. Capabilities and co-capabilities. Actions. Okay. Can enter into ambient N. All right, so there's some papers I might have to read to understand that.
I was hoping the guy should be on yesterday to go over this or to look into this. It looks very interesting, but I haven't gotten too deep into it.
On the Casper stand-up, maybe a week or two ago, Greg was talking about ambient calculus and its relationship to row calculus. Now, I have to go back and listen to the Casper stand-up again to remember the conversation, but understanding ambient calculus helps, this environment that everything's happening in. In that time, I was the first time I heard of ambient calculus, so I was kind of thrown off, but I got a sense that this picture that we're trying to create, understanding ambient calculus and its relationship to rote calculus, and this architecture of this environment that we're creating, it starts to the mysticism starts to disappear, and it kind of gets you to helps with the understanding. Now I have to go back and listen to that Casper stand-up again.
I don't know if I missed that one or.
So it wasn't this past Monday. I want to say it wasn't the Monday. So this is the 27th. So let me see if I have a date on that.
But, whoa.
So it was either let's see, that was 22nd. So it was either the 15th, July 15th or July 8th. Greg talks about ambient calculus. I don't think it was as far back as July 1st, but I think it was either the 8th or the 15th.
Yeah, well, most of this stuff is 3 days ago, from 3 days ago. In fact, so this is brand new.
Oh, maybe it's
the calculus isn't new.
Right.
But
this update is. Yeah.
Protocol.
Okay.
White paper.
Yeah.
Do they have anything that makes it go?
Well, I'm trying to. I mean, it seems like okay. It provides verifiable DAG of what's been executed. It's not clear to me how that's, how that's, I mean, it doesn't have any global consensus or anything.
Doesn't look like there's a lot of there.
There's not much there.
If there is, I'm not seeing it. I mean, they don't have any software that actually, I mean, it's like RChain in 2016, right?
Right. They're waiting for someone to take their white paper and put it into Idris and start creating something.
Yeah, I don't know if they're going to use Go or C or Scala or who knows what they're going to do. Rust. Future work. Early implementation efforts are focused on covering the most common operating systems and hardware architectures, as well as supporting browsers, future IoT devices.
I gotta
So
step away.
JavaScript and assembly.
I'll be right back.
All right, thank you. It would be good at some point if on one of these computational calculus things we sort of compare ambient calculus with the row calculus and try to get some understanding of how they are related or different. I mean, I was getting, that this looks interesting. Was this a reference or you just found this?
It was in the future work thing. AmbiCobj or something has been a crucial tool in designing the protocol. The one thing that they might have that our chain hasn't gotten to yet is types. Because they talk about verifiably safe and stuff. That was another thing that was almost on my list today, but I didn't get it quite written down, was looking at the ERTP sort of
Electronic rights transfer protocol. Yeah, that's Gary's interested in that.
I was interested in looking at the ERTP formalism and seeing if it makes sense in behavioral types. See how much of it can be captured with behavioral types.
Okay.
$5 months. How much of this did we get done? This is another slightly different process, calculus, but they have a bunch of the type checking worked out. Okay, I think I'm going to play with my toy some more.
Cool.
All right,
Well,
talk to you later.
Yep. Thanks, Dan.
Thanks, Dan.
Yep. See you guys later.